Hello guys, so last time we have discussed that what is mean by stability, causality, linearity, time invariance and memoryless or memory oriented systems. So today we are going to talk about different parts of our questions, and we are going to see that whether the systems given in each of these parts fulfills the criteria to be stable, causal, linear, time invariant and memoryless or not. Okay, so to solve it I have created this table, and if a system which is given in A, B, C, D, E, F, G, H fulfills some criteria, I will indicate it here. Otherwise, I will also indicate it here as well. Okay, so let us first solve part A of my question. So in part A, the system given here is y of x is equal to the t of x of n. Okay, sorry, this is n. Okay, so what is this? This is basically the input here, which is x of n. It is passed through this t transformation of this system and give me the output y of n, which is basically t of x of n. Okay, so this is for your understanding that what is meant by t in each of these questions. Okay, so once you have understood it, let's move on to our question here. So the question here is t of x of n is g of n x of n. Okay, when x of n is applied, it will be multiplied with this g of n. Okay, so the first part is to see that whether the system is stable or not. So the stability of it is, we have to check the stability of it. So in order to see that whether the system is stable or not, so if the value of g of n is under some bounded conditions, so x of n, if bounded, the output will be bounded as well. So it solely depends upon g of n. Okay, so if this is bounded, the output will also be bounded, because x is bounded, then y of n will also be bounded. So this is for the BIBO bounded input, bounded output condition. So here the stability is solely relied upon this g of n. So if this g of n is given and this is stable, so the system will be stable. So let me call it stable. So here the system is stable. Okay, I have indicated it. Similarly, now the second condition is causality. So as I have previously indicated that what is meant by causality, so if a system will only depend upon its present or the past values, the output of it will be causal output. Okay, so now here we can see that if t of x of n minus n naught, this is the previous value, the output will also be g of n x of n minus n naught. Okay, so this is what we have here. Okay, so whatever the input will be, the output will depend upon it. So you can see that this is the input to this system, so the output is in this form, which means that it is only dependent upon the values of the input given. Okay, so therefore the system is also what? The system is also causal. Okay, this is the second condition. Now in order to see the linearity of a system, let me remove these two. So as I have previously stated that the system will only be linear if it will follow the conditions what I have previously told you, that it will be like this one, that it will be the same system. Okay, then it will be added together here. Okay, this is the multiplicative factor, this is the multiplicative factor as well, and here we get a. And similarly, if the same system is here, that this is one, we have the similar multiplicative factors here, we have got them, we have added them together. Okay, and after it we will pass it through the same system. Okay, which is here, here and here. Okay, so the output of it will be B. So if A is equal to B, the system will be what? The system will be linear. Okay, so let us formulate it for this system. So this is x1 x2, this is x1 x2. Let us do it for this system. So here in this system it will be, let's first do it for this one. So it will be the system with which the multiplicative factor is A and it is multiplied with x1 of n. Okay, and for the second one we have what? For the second one we have this. For this one we have here, let me have here this B, this is A, so here it will be x2 of n. Okay, so this is what? This is for our first system. Let me call it equation A. Now for the second system which we have here, to find out the transformation of it, the system will transform all of this, in which A multiplied by x1 of n plus B into x2 of n. Okay, what has happened here? Let me indicate it. So this is what? This is the procedure which is followed here, and then this is the x1 of n, and then this t is here. Okay, this is the transformation. Similar is for this overall system which is here for this one. Okay, this overall, this is here, this is the output here, this one is the output here. Okay, these two are added together as are here, and this transformation which is t, this has been done here. Okay, so I hope you have understood all of this. So let me remove these red lines and solve it. So once solving it, what we will get here, we will get t of A x1 of n plus t of B x2 of n. Okay, we can see that these are the constants. These can come out as well. So this will also be here, this can also be here, and this can also be here. So this is the equation B. So here we can very easily see that A is equal to B. Equation A is equal to B. So it means that the system we have is linear. Okay, so the system we have is a linear system. Okay, so I have indicated it. So the third one here is the time invariance. So in order to check for the time invariant system, what we have done, if the input is x1, okay, it is first delayed by some delay and not, and then it is moved through the system. Let me represent it with this t. The output of it, let me call it capital X, and if this similar input is applied first to a system and then this is delayed after it, the output, let me have here y. So if x is equal to y, the system will be time invariant, otherwise the system will be time variant. Okay, so let me apply the similar formulation here. If the input we have here is a system which is here, so first if x1 is applied here, here we will get what? It will be x1 n minus n naught. Okay, and then through the output of it will be x. Here would be the only thing it will multiply with it is g of n, because here you can see that it will multiply g of n with the input. Okay, so here the output of it will be x1 n minus n naught. Okay, so this is for x. Similarly, is this second system in which the same input has been applied here. So here we will get what? We can see that here we will get here x1 of n and g of n. Okay, so the output of it here is well, and once the delay will be applied here, the output of it, which is here, both of these terms will be delayed simultaneously. So here we will get n minus n naught. multiplied by x of n minus n naught. Okay, so we can see that x is not equal to y, so the system here is not time invariant, but the system here we have in part A is time variant. So therefore let me indicate it here as well. So the system here is not time invariant. Okay, I have indicated it here as well. Now in order to see that whether the system given here is memoryless or has a memory, we have to check that whether the output depends upon some previous inputs or not. So it is clear that t of x of n only depends upon the input at a time. Okay, we can see here that here if t of x of n naught is applied, the output here would be what? It would be g of n naught multiplied by x of n naught, and it will not depend upon any previous of the inputs. Okay, so therefore the system here is memoryless because it is not storing any previous values, so therefore the system here is memoryless. Okay, so in this way we have solved part A of our question. Okay, so that's it for today, in which we have solved part A of our question. In our next video we will try to solve each of the parts given here. Till then, take care of yourself. If you have any question related to any of the parts here, please ask me in the comment box. See you soon.